All right, so we're going to be starting our trigonometry unit. Trig. Okay, basically what trigonometry means is that you're going to be working with triangles. In this year, we're only going to be working with right angle triangles, ones like this. We're not going to do any triangles that are not right angle, so stuff like that. Scaly and isosceles, no. It's always going to be right angle triangle, which means it's always going to have that 90-degree thing in the corner. So, before we figure out these triangles, we have to learn how to label these sides. There's three important words we're going to be using. Okay, these are the three words we need to know. Hypotenuse, which you hopefully have already learned from previous years, is the long side. Okay, the hypotenuse is always across from the 90-degree angle. So in this case, this is my hypotenuse right here. Okay, for this triangle, it's right here. If we scroll down to one like looks a little bit different, it doesn't matter which way the triangle is facing. That one's the hypotenuse because it's across from the 90-degree angle. So I like to write at the start, label my hypotenuse as H, so I know which one it is. It's going to be important when we do with what we do next. Okay, the adjacent, let's make that red. Adjacent means beside. And then opposite, well, means like across is a way of thinking of it. So the way we're going to label the besides, the adjacent and the opposite side is we need to figure out which angle we're looking at. So let's say for this triangle, we're looking at this angle right here. That's the angle I want to find. I want to find out how many degrees is it to go from here to here on a protractor. And in this triangle, we'll do this angle to make it different. Okay, so for this first one, from this angle, I need to figure out, okay, what side is beside that angle? Well, if we look at it, this side right here, this edge of the triangle, is the adjacent side because it's right next to it. You would think it might be this side, but this one's already the hypotenuse. That's why we do the hypotenuse first, and the adjacent is the one that's beside the angle that isn't the hypotenuse. The one I like to do next, honestly, is the across one, the opposite. And when we look from this angle, going all the way across to the other side, that is our opposite side. Okay? Now, let's do it again on this triangle. You look for a sec and you try and figure out, okay, which one's going to be my opposite, which one's going to be my adjacent. Okay, so adjacent is this one because it's right beside that angle, and then the opposite is this one because it's all the way across the triangle. So we needed to label those because we're going to be working with a formula here. The formula we're going to do, oops. Okay, we're going to be doing tan theta, this is just an angle, is equal to opposite over adjacent. This is a really cool formula that we're going to be using, and it will help us solve all of these triangles. This formula, you can have it written down, you can have it, you don't need to memorize it, but you need to know how to use it. So I'm going to give you two examples, and then we'll do some practice questions from the worksheet. So, looking at this first triangle, let's give it some numbers, 8, 12, whatever. Okay, the very first thing I'm going to do is I'm going to label the three sides. So I've got, okay, across from here is my hypotenuse. And we're going to find this angle. Let's find that angle. So we got the hypotenuse there, the adjacent's going to be this one, and the opposite's going to be this one. So what I'm going to do is I'm going to write my equation, tan theta equal to opposite over adjacent. And now I'm going to fill in the numbers. My opposite side was 8. 8 centimeters, it doesn't matter, just it's 8. So I'm going to put 8 for the opposite. Okay, and actually let's use some colors to make this easier. Opposite, opposite, and then adjacent, adjacent. Adjacent's going to go here, and it's going to be 12. Okay? So we have tan theta. This is called theta. It's a Greek word, it's a Greek letter, like A or whatever. It's just used for that angle. Theta. Okay, tan theta is equal to opposite over adjacent, so we said it's over 8 over 12. So now what we're going to do is we can actually do this. Tan theta is equal to, when I do 8 divided by 12 on my calculator, I actually get 0.66666, which is fine. Okay. The last step, I want to just know the angle by itself. So what we have to do is we have to actually like move the tan to the other side. This is going to make it inverse tan 0.66666. Okay. On your calculator, you probably have a button that says tan, and then what you'll have above it, usually over, on mine it's on the top left, it'll say something like this. Okay, it might be like an orange font or something like that. What you have to do to make that button work is on your calculator, you have to press the button that says like second function or something. It's usually at the top left of your calculator. Okay, it'll be like there. So you have to press this button and then press tan, and it'll make the second function work. On most calculators, if yours has a screen, it'll then say this, and then you have to put the number in. Some calculators don't have that, and you have to press the number 0.66666 and then press the inverse tan button. If you're having issues with how to do this, let me know in class and we can go over, like I can make your calculator work. But so what I'm going to do is I'm going to press that. I'm going to do inverse tan of 0.66666, and it's going to tell me my answer. Okay, it gave me about 33.6666 degrees, so that's about 34 degrees. Okay, which means that that angle right there, the one we found at the start, is about 34 degrees. Cool, that's the basics. So now let's do another example. Let's do this one right here. Let's do it with different numbers, whatever, like 10, 16, okay? So I'm gonna write, okay, let's label my sides. We have, this is the angle, so across from this is the hypotenuse. We're gonna solve for this angle this time. And again, in the question, it'll give you the angle. So for example, in this one, it gave us X here, so that's the angle. This one, it said Y, so that's the angle. So we have that. Let's label, this is gonna be adjacent, this is gonna be opposite. So I'm gonna start by writing my equation, same as every time, tan theta equals opposite over adjacent. I just write those 3 letters because I know what they mean. Then I'm going to put in the numbers. Opposite was 10. Sorry, opposite was 16. And adjacent was 10. And then that gives me 1.6. And then I have to do the inverse tan on 1.6. And it gives me 58, about 58 degrees. So that means that that angle right there is 58 degrees, and that's it. That's all it asked me to find. So we're going to do these two, which are the very first 2 questions. What I would suggest is that for this, if you want to write down a note, something to yourself on that front page, the important things were this one about how to label the sides, and then how to use this equation. Those were the 2 key things. Oh, and maybe like what each of the letters stands for. Now we're going to do the first 2 questions on the worksheet to make sure that you have examples written down so you know how to do the rest of them. So I'm going to write this out. The first thing I'm going to do is label the sides. I know this is the right angle, so this is the hypotenuse. This is the adjacent because it's beside X, and this is the opposite over here. I'm going to write out tan theta equals opposite over adjacent. Then I'm going to sub in the numbers, so I have 3 over 5. And then I'm going to, when I do that on my calculator, you get 0.6. Then I'm going to write, theta is equal to inverse tan 0.6, and that will give me my answer. For me, it gave me like about 31 degrees. Let's do the second one. So it's going to be the same thing. Let's label our sides first. So we have, this is the hypotenuse, obviously. The opposite is all the way over here, and the adjacent is here beside it. So let's write in our numbers. We're going to do tan theta equals opposite over adjacent, same as every time. Then we fill in our numbers. Opposite was 4. Opposite was 4 because it was over here, the opposite. Adjacent is 6. So we go tan theta equals 0.666. This is actually the same as the example we did before. Then we're going to do theta equals inverse tan 0.6666. And it gives us the 33 degrees. Cool. So that means that that is 33 degrees on a protractor. That's it. There is going to be questions we'll do the next section where you actually have a triangle. It gives you the angle like 71 degrees and it gives you a side, and then you have to be able to solve the missing length. For now, we just learned how to find those angles because I think it's a little bit easier. The important thing to remember, these are the takeaways. Label your sides, opposite, adjacent, hypotenuse, that's the first thing. Then write the equation. Sub in the side lengths. And you solve it by using that inverse tan thing. Okay? So, try to do the rest of those practice questions. Use these as examples, and we're going to work on these more in class.